Hi, today I'm here at Point Defiance Park, looking for some math around town. Flower petals, plant leaves, and pinecone scales create patterns that can be understood with fractions. Imagine the center of a flower surrounded by 360 degrees of space, which can be thought of as one rotation. Each petal growing out of the center of the flower is separated by the same amount of rotation, resulting in the fraction 1 over something, where 1 is a full rotation. Now let's see what happens when we put different fractions as our amount of rotation. At 1/2, we get 2 flower petals that extend out. At 1/3, we get 3. At 1/4, we get 4. And this pattern continues where the denominator will give us a number of petals. If plants continued to create new petals using these rational fractions of a rotation, the petals would extend in straight lines, leaving plenty of open space. To reduce the unused area and minimize overlap, the denominator can be chosen as an irrational number, that is, a decimal that never ends or repeats. Examples of irrational numbers are pi, square root of 2, or the golden ratio, phi. When we take 1 divided by one of these irrational numbers and use that as our amount of rotation, we see spirals start to form, less overlap of petals or leaves, and less open space. Does this happen in nature? Look at this intact pine cone. The pattern of scales agrees with the rotation 1 over phi. Can you find other examples of plants whose growth uses an irrational rotation? Can you find examples of rotations of 1/6, 1/7, 1/8? What is the largest denominator you can find? Look around you. Math is everywhere.